Hello, I'm Raul and I'm going to present you the latest Timekeeper power amplifier from Burson Audio. We're talking about a couple of monoblocks. That means that each of the two amplifiers are handling separate channels. Basically, I can choose this one to be for the left channel and the other one for the right channel. As an audio source, I'm going to use for this presentation the latest conductor. Let's see what this new design is actually bringing on the market, comparing with the previous GT3. By looking purely on the specs and presentation page provided by Burson, we can easily see that the previous version was able to handle up to 180 watts, while the new version is actually able to handle 200. At least this is what Burson is stating. We're talking about 4 ohms speakers here. The previous version was actually using a V6 op-amp in the input stage, while the new version, this one here, is using their latest op-amp, which is V7 Pro, the Vivid one, which is of course swappable. You can change it with any other op-amp that is compatible with V7. The so-called MCPS, it's a max current power supply. It's basically a DC-DC power converter, like a boost converter actually. To be able to get so much power, speakers, you need to use quite a high amount of voltage, and the power supplies are probably feeding each monoblock amplifier with 36 volts. I don't think this is enough, so they need somehow to increase the voltage and to make it 2 rails voltage to double the voltage that gets onto the output stage. I'm not sure, maybe it's 70 volts, maybe it's less, it doesn't matter right now. What's important is that they are developing their own DC-DC converters and they are calling it a max current power supply. Now, I see that they have a little bit different design. We'll see about it in this new version. They are using different DC-DC converters. And one new thing, they are using the fusion core, which is somewhere in the background. You can see 3 power supplies, like huge ones. And we'll talk about these later. We have a rather big Noctua fan on the previous version, while on the new one, actually there are a couple of fans, smaller ones, one on the right side and the other one on the left side. They are small and basically virtually silent. While with the Noctua you were able to hear it from about 2 meters. This one from 2 meters, if only one unit is powered, you may not be able to hear it. Oh yeah, the signal to noise ratio, it used to be 108, now it's 110, so yeah, 2 dB. Better signal to noise ratio. We are having the same input buffer gain, 6 dB for the unbalanced RCA plugs and 12 dB for the XLR balanced. We see an idling power of 100 watts here. Same here, same on the previous version. And what idling power means, so basically if I power on the device, it's gonna start feeding from the mains outlet about 100 watts without singing, without amplifying any signal. And why is this actually happening? because it is written here. Let's see exactly. Or it was written somewhere. Okay, here. So he's able to output the first 30 watts from the power in pure class A. And that means that the output transistors are actually biased with a lot of current. And this is why we're getting 100 watts power consumption without actually outputting anything on the speakers. Some might say that is not very energy friendly, but most audiophiles are actually finding the class A as being superior to other audio technologies. Now, I'm not going to get into details because from what I've seen and what I've heard, each class of amplifiers are actually, if well implemented, are actually able to sound neutral and with a very low THD. There is a huge power supply here. Look, the other version, it was using a 32 volts, 6.5 amps. 32 volts, 6.5 amps. That's 208 watts. Alright, 208 watts to deliver 180. It's plausible. Yeah, I mean, this is not a linear PSU, so it probably has like 90 something percent efficiency. Is totally plausible. But on the new power, on the new Timekeeper device, they are using these babies here, which these are 32 volts, 15 amps. That would be 480. Of course, they are using, they are providing the Timekeeper with another Burson supercharger, which is 224. I think it's okay. 224 watts to deliver 200 is doable, but with 480 watts fusion core, one for each monoblock, I wonder how many watts we'll be able to deliver. I think I'm just going to power it on. I had them connected via trigger cable. I have a trigger cable coming from Burson conductor to the first Timekeeper, and another cable from the conductor to the second Timekeeper. Why am I using trigger cable? Because I don't want to press 3 times on the power to open them up, and again 3 times on the power button to power them off again. That's one thing. And the second thing, if you have speakers connected, you never know what will happen if you turn off the power on the audio source prior to cutting off the power on the power amplifiers. Maybe there's a thump noise that might actually be heard on the speakers. And this is something that we don't want to hear. And we don't know if the speakers might actually resist. It really depends on the audio source. You don't know the audio source, how it's designed, and if it's cutting correctly the power or not. So using the trigger cables, you just make sure that when you power off the audio source, it's going to automatically cut off the power on the power amplifiers as well. And this is what I'm going to do now. I'm going to power them on. That is a small whining noise, probably coming from the power supplies or from the coils from the DC-DC converters. It's pretty normal, actually. There is a blue light here, right? This blue light tells me that the gain chosen is actually 0 dB. If I want to increase the gain for any reason, I'm just pressing a button on the back side, and there is this greenish cyan color that tells me that now the gain is 6 dB plus if I'm using the RCA unbalanced inputs, and 12 dB plus if I'm using the balanced XLR. Also, there's another button for switching the inputs. Now this is RCA, this is XLR. This is XLR with plus 12 dB. This is RCA with plus 6 dB. So you can probably memorize the colors, or just keep it one way like I'm doing. I'm only using the XLR balanced inputs, and I don't really care about any gain at the moment. I mean, the audio source I'm using is able to provide enough juice, so yeah, I don't care about the gain at the moment. Are you hearing the fans? I am able to hear it. Yeah, I'm not sure which one is louder, maybe this one, I don't know. So basically there are 2 fans on this one, 2 on this one, and 2 on this one as well. So 6 small fans. The microphone is actually 2 or 3 inches, 2 inches away from the Timekeeper. If you can hear the fan, do let me know in the comments. I'm going to cut off the power, which will cut off the power on the 2 amplifiers as well. So yeah, a great advantage of using the 12 volts trigger cables. I totally recommend that. It's impossible to hear any noise. No mains hum, not hissing, not anything. So while I was testing it, I was placing my ear straight on the tweeter, and I'm talking about 92.5 dB SPL at 1 meter sensitivity, 92. So with 1 watt, you're actually able to output 92.5 dB SPL. So quite sensitive speakers, not extremely sensitive, but still, with Timekeeper powered on and my ear sticked to the tweeter, I got nada. Absolutely no noise, no hiss. How is this possible? Initially I thought that without music, it has some sort of cutting the power off, but no, this isn't the case. Absolutely not at all. So I don't know how they were able to do it, but I was unable to hear any noise with my ears sticked on the tweeter. That is impressive, especially for 200 watts power amplifier. What I actually love about these are the factor 4, the look, the size, and the fact they are not overheating. And I'm going to power them on now. Usually I would expect the heat to be dissipated by more noisy fans, but this is not the case. So that's a huge pro to me. These babies are actually having a very pleasant sound, very pleasant output sound. I was able to hear every detail from the test tracks without needing to focus a lot. I didn't even need to use a lot of power to be able to hear all of these details. So I'm pretty sure I wasn't using more than 30 watts per channel, meaning that I was able to do a proper critical listening, critical auditioning, without getting out of Class A amplification. Maybe this is the reason why I did like the sound, and maybe this is the reason why I was able to hear somehow more details that I was hearing with my Marantz or with my Yamaha amplifiers, where to be able to hear the same amount of details, I needed to crank up the volume a little bit more. Maybe the V-Wide, the V7 V-Wide op-amp is doing something, and it pushing forward somehow the details. I don't know. I'm just trying to guess here. But thing is, I could hear more details with the Timekeeper than with other amplifiers I have at home. And I was using about the same output level. And yeah, I have an SPL meter. I was using a test signal for, depending on the test signals, I was using 80 dB, SPL 85, 90 dB. So basically same volume, same output level, more details, and more pleasant sound as well. Usually, detail sounding amplifiers might be labeled by some as being clinical and fatiguing, but in no way it is clinical sounding nor boring at all. As a matter of fact, it has a warmish sound given probably by the V7 V-Wide op-amp and by the transistor output stage made around the British company named Exicon. There is no way to get bored by listening to Timekeeper GT4, not even after several hours of continuous listening. The trebles are not scratching to your ears, the bass is not distorting, you just hear the natural sound of music, nothing else. Temperature is below my expectations. Actually, after a couple of hours of powerful listening, I wasn't even reaching 50 degrees Celsius. As a matter of fact, in the rack, so both units rack mounted, I was barely getting past 43 degrees Celsius. I wonder if this PSU will actually help the Timekeepers to sound better, and why not to measure better in terms of power, in terms of maybe distortions. This is my in-house setup I was using to measure the output power of these Timekeeper amplifiers. The DC resistance I was able to measure was about 4.5 ohms, where wires resistance was close to half ohm. So it's okay to consider that the resistors mounted on the heatsinks are indeed having 8 ohms. There are two 8 ohms powerful resistors mounted in parallel, meaning 4 ohms. I was using gold-plated banana plugs connected to 4 square millimeters copper wires tied up together through Vago 32 amps connectors. For measuring the output power of Timekeeper, I was using an USB-isolated oscilloscope connected to a battery-powered laptop. I was choosing a higher input voltage for my scope probe to ensure that there will be no clipping. Then I selected the output of the Burson conductor, which will be used as audio signal generator by playing 1 kHz audio sine waves. I was also using 443 Hz audio files, but also pink noise too, and I got pretty much the same results. Worth mentioning that the real music power is much higher than the synthetic power I am measuring here. I am also not recommending anyone to perform such tests to protect the amplifier from getting into thermal or current protection, which might happen on longer testing procedures. I am gently increasing the volume until I see the first signs of distortions. I need to carefully look on the top and on the bottom of the sinus, and when it starts to get flat, it means that it starts to distort. I can see that on 34.63 volts, which means 300 watts of RMS power, the sine waves are slightly bending on both top and bottom ends, meaning that slightly distortions appear, probably at around 1% or perhaps a bit more, but definitely inaudible when playing real music. We are now talking about 300 watts RMS delivered into 4 ohms dummy load resistors, which is already 50% more power than the one indicated by the manufacturer. Lowering the volume to 31.63 volts makes the distortion to disappear. This is about 250 watts. Then rising again the volume to 32.87 volts, which is 270 watts, will slightly start the top of the sine wave to bend a little bit, telling me that this would be the highest output power without any signs of visible distortions on my oscilloscope. I am impressed that when using a more powerful external power supply, this amplifier is able to deliver up to 50% more power than it's written in the specs. Most likely, the specs were written for the supercharger power supply, which only delivers 224 watts, while the Fusion Core delivers 480 watts, so more than double. Once again, a beefier and stronger power supply can influence the output power of an amplifier and, at the same time, could lower the audio distortions when using a higher output volume, especially when bass is kicking louder. However, the actual music power is definitely above 300 watts, but now I'm mostly interested in what the true RMS power Timekeeper GT4 is able to deliver when using Fusion Core external power supply. I've also measured the output power on 8 ohms dummy load resistors, and I've noticed that after 36 volts, meaning 160 watts, it starts showing the first signs of distortions on both sides of the sine wave signal. However, lowering the volume just below 35 volts, meaning a bit over 150 watts of RMS power, will completely eliminate any signs of visual distortions. That makes me thinking that the maximum RMS output power of the Timekeeper GT4 under 8 ohms load will be anywhere between 150 and 160 watts. Of course, by using real music tracks instead of these stressful sine waves, the output power will be definitely much higher, but what I care about right now is to get the absolute maximum power these Timekeeper amplifiers can deliver under the most stressful conditions. Now let's see the backside of the audio rack Burson Mothership 03 to see what's inside and how the wiring is routed inside the main piler. Just need to lift the lid up and to slide the side cover to get access inside. There is plenty of space to fit several wires, even thick balanced ones, but also a small Thunderbolt USB-C mini docking. This mini docking is powered from an external Apple power supply, and then it feeds my MacBook Pro placed on the top of the rack. It also interconnects the Burson conductor with the MacBook, and it can hook it up to the Ethernet LAN port if needed, given that there is room inside the rack for an additional Ethernet cable as well. I have the Burson conductor in here, the power cable coming from the AC adapter here, then all the balanced wires that come from the conductor to the Timekeeper amplifier units are properly routed through the piler of this audio rack. Let me see if I can place it back with one hand only. Yes, it works eventually. All I need is to push the side cover gently and to keep an eye on the inside wires that might block the cover while sliding it down. Now, placing the top cover is easier due to the strong neodymium magnets included. It's time to see some guts from inside the Timekeeper Grand Tourer 4. It came with an Allen key, but I'm not going to use it for now, given that it might be faster to use my own screwdriver and tools. The two low noise fans are used to exhaust the hot air outside, and they are connected on the board through regular 4-pin plugs, like it's done to normal home computers or laptops. We have the power regulators in here that are taking care of delivering a high amount of power to the output stage created around Exicon lateral MOSFET transistors. These are called by Burson MCPS, standing from Maximum Current Power Supply. We're basically talking about high-quality DC-DC converters with powerful MOSFET transistors and big coils covered in thermal shrinking tubes that keeps them from generating unwanted vibrations inside the amplifier. The input voltage comes from the external power supply through the big plug, in our case the fusion core. Then it gets filtered again by the electrolytic capacitors from the entrance. We also have some additional low noise regulators named by Burson Silent Power, which are powering the Burson V7 V-Wide operational amplifier and the internal preamplifier made out of transistors. There is also a big relay used to connect and disconnect the attached speaker. It is very helpful to minimize thump noises that might appear while powering the amplifier on or off, but also to disconnect the speaker in case an internal error occurs, like, for example, overheating or too much power that could cause the amplifier to clip and distort about the limits. This chip over here checks for any DC voltage on speaker output connectors and, along with the big relay mentioned, it will protect the speakers when needed. We have the two XLR and RCA inputs here, the relay that switches between XLR and RCA inputs, then the second relay that adjusts the gain. This is connected to the small gain push button from the backside, 0 or 6 dB for the RCA input, then 0 or 12 dB for the XLR input. These are the powerful MOSFET transistors that create the so-called max current power supply regulators. These are 45 amps MOSFETs able to dissipate up to 160 watts and are driven by a couple of low-noise linear technology DC-DC converter chips. These MCPS regulators deliver an instantaneous high amount of current to the output stage transistors. We have here 6 powerful ceramic wire-wound resistors used to bias the amplifier into Class A or Class AB, depending on the output volume used. We also have an interesting infrared optical barrier here. It's a circuit that triggers an alarm and powers off the unit when the top case gets open, so nobody will be able to use the amplifier without the top case. This is common sense, given that it's using 2 fans tied to the top case, so without the top case there will be no fans able to get the hot air out properly. There are plenty of low ESR aluminum polymer capacitors installed on the board to get rid of any AC ripple and noise that might appear on the DC regulators. Also, having many capacitors close to the output stage transistors will ensure enough current flow in cases where a lot of bass is needed, so it helps in instant delivery of current. These are the powerful lateral MOSFET transistors manufactured by the British company Exicon, specialized in this type of transistors. They are used in output stage only, so they're tied directly to the speaker. They can deliver a continuous current of 8 amps and can dissipate a power of 125 watts each transistor, and in one single monoblock amplifier we have no less than 6 of them, so quite an oversized output stage for a 200 watts amplifier. The 4 feet from the bottom of the case are made out of rather soft rubber, very good in absorbing vibrations, although if we're using the Burson Mothership rack, this may not matter much, but for those placing the Timekeeper on hard surfaces, this fit really comes in handy. Besides absorbing vibrations, they are also anti-slippery. I'm now going to place the cover back. I need to take care of properly aligning the aluminum channels from the upper side with the opposite channels from the bottom side. Then I need to connect both 4-pin connectors from the 2 small fans. There is a lot of aluminum here. Quite a beefy heatsink gets created when I'm finishing screwing the 4 screws back in. Now, I understand why the Timekeeper temperature while running is not increasing as expected. I guess that this big heatsink along with the 2 noiseless fans are really doing a great job. Okay, now I'm done assembling it back. Thank you for watching.